First of all, I want to talk about objective of this experiment. In this experiment, we want to determine the coefficient of static friction of different surfaces. Theory of this experiment. Force and velocity are vector quantities that have both magnitude and direction. Velocity is the speed in a specified direction with which a given object is traveling. A body at rest or in equilibrium its Heibig resultant force or the sum of all forces acting on the body is zero. Normal force is a contact force that acts in the normal direction or perpendicular to the contact surface between two objects. The apparatus that we use in this experiment. We use wooden block, rubber cover at one side, 50 grand masses, 10 Newton spring scale, string and tabletop. In this experiment, we have 9 steps that we must follow. First of all, the mass of the wooden block was measured and recorded as m. The apparatus was set up as shown in figure 5.2 above. The tabletop was checked to ensure it was stable and horizontal to the ground. The spring scale and the wooden block were attached with a string. They were placed horizontally on the tabletop. The rubber side of the block was faced downward. Next, 50 gram mass was placed on the wooden block. Number 6, the spring was pulled slowly. Once the block started to move, the spring scale reading was recorded. The value was recorded as F and tabulated in table 5.1. Steps 4 to 6 were repeated for 3 trials. Another 50 gram mass was added on the wooden block and steps 5 to 6 were repeated. The steps were repeated until a total of 500 gram mass was on the wooden block. Steps 1 until 8 were repeated. This time, ensuring the rubber side of the block was facing upward.
So this is result and data for mass of wooden block with rubber surface, which is m 132.23 plus minus 0.2 gram. Next, this is result and data for non-rubber surface toward the floor.
Analysis of the experiment. First, draw and label the free body diaphragm of the wooden block. At the top of the wooden block, we have normal force. At the right of the wooden block, we have force. At the bottom of the wooden block, we have weight equal mg. And lastly, at the left of the wooden block, we have frictional force. Second, plot graph of static friction force against normal force for the rubber surface and non-rubber surface. From this experiment, we have to graph is rubber and non-rubber. 3. Use the gradients obtained from the graph to calculate the coefficient of static friction for each surface. To calculate question 3, we have to find gradient equal coefficient of friction. For rubber, equal 3.2 minus 0 over 4.73 minus 0.8. This answer is 0.81. And for non-rubber, equal 0.75 minus 0 over 4.00 minus 0.3. This answer is 0.20. 4. Compare and discuss the coefficient of static friction obtained. Coefficient of static friction for rubber surface towards the floor is greater than non-rubber surface towards the floor. It is because rubber produces more frictional force than non-rubber.
Question: how can anti-lock brakes stop a car in a shorter distance than regular brakes? Anti-lock brakes let a car stop quicker because they keep the tire biting the road instead of letting them skid, and that extra grip give the driver more control. From the experiment, which material have the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determine the coefficient of static friction? In this experiment, the wooden block with rubber surface has a high coefficient of static friction than non-rubber. Yes, I agree with my hypothesis. It is because when a surface is raw and sticky like rubber, the coefficient of static friction climb well above what you find on a slick material. I think when a surface is raw, small peak and valley blend into each other, causing increased friction. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. When the mass begins to slide, it's moved to undergo stop and go, also known as stick slip motion. It is because the amount of friction that intersurface interaction can provide is limited, not unlimited. To prove this, the subject will provide a vertical downward, which is called normal force, causing a friction force between the object and the plane. A body at rest remain at rest, or if in motion, remain in motion at a constant velocity unless on by a net force. An object sliding across a table or floor slow down and goes back due to the net force of friction acting on the object.
So, the conclusion for experiment frictional force is, from the experiment, we were able to find the coefficient of static friction of the rubber surface. Although we only test one type of surface in this part, the results show that surface texture affect the amount of friction. The experiment clearly showed that raw surface like rubber have higher friction compared to smoothest one, and it helped us understand the relationship between surface type, mass and friction. So, the objective to determining the coefficient of static friction based on surface was achieved. So, this is our reference for this experiment.